Hello, my name is Shadi. My partner is Raja. Unfortunately, he's not here today because his visa expired 2 days ago, which was so close to the finish line, and which shows he's really sad to not be here. But I'll try to convey as much of his work as possible during this 5-minute presentation. Our project is with Enel. The supervisor of our project from Enel is Senior Data Scientist Fernando Gargiulo, who's sitting over there. I never needed to pronounce his last name because he's so friendly with us, so I'm not sure if I pronounced it right. Our mentor is Nicolas von Rose, CEO of TVT. With both Fernando and Nicolas, we have weekly meetings, once, sometimes twice. And I also have one daily meeting with my 1-year-old daughter who's punching on my keyboard, trying to delete my files on the laptop all the time. So our project is AWS Resource Optimization. If you already noticed, Enel has sponsored several projects in school here. It shows how data-driven they are. To be able to analyze so much data, you need computers. You could either buy your own computers and have them hosted in your own headquarters, or you can use a service that Amazon is providing to allow you to rent computers through their website and access these machines without needing to invest into hardware on your own site. This makes it super easy for you to launch new machines, big machines, small machines, all kinds of machines, cheap ones, expensive ones. And Enel used to have hardware and machines on their site until 2016, where they completely migrated into Amazon's cloud. This migration saved them 20% of costs. But because Amazon makes it so easy for them to create new machines, this makes it easy to also kind of become a little bit wasteful. So even though they saved so much in 2016, over time they start creating more machines, and our project is about seeing how can we save in this wasteful behavior that Amazon makes so easy. With migrating into the cloud, Enel has also been able to tackle the Internet of Things. So lots of small devices which are lying all over the place in houses and factories, and because of the huge number of these things, you need to be able to quickly release new machines. But the question is, with this huge number of machines that you need, did you really make the best choice because you have so little time to decide? With migrating into the cloud, Enel was able to reduce the time to satisfy requests from 4 weeks, so requests for new servers, down to 2 days. That's huge for users, and they're super happy. But then there still remains one single problem. A user who doesn't have a lot of sense of responsibility can come and say, I want the biggest machine that Amazon has. And what we try to do with our solution is try to find a way that is data-driven, that helps the user identify what is the wisest and most responsible machine that I can take and still perform the task that I have. So, in terms of cloud costs, you can either go to your accountant who will just give you one list of negative numbers, and you would hate the accountant. What we did was we built a solution that will allow you to separate the costs in different groups, and these groups were identified purely from the data, using CPU network and partially RAM data on 5-minute intervals. Because of the large-scale infrastructure, Enel on any particular time has 20,000, almost 20,000 running machines. What our solution does is it tries to group them into smaller categories. So we did a divide and conquer. And in these smaller categories, we try to say, okay, for these ones, we suggest you do this to save this much money. For these ones, we suggest that you stop them because maybe they're not doing much. For the other ones, maybe you want to use Amazon's service called Lambda Functions, which is a serverless computing service. In terms of requests for new servers, as I already told you, our solution is suggesting to the user the best, wisest, and most responsible instance that the user can take. In terms of value, Enel spends $50 million per year on Amazon. Enel's income per year is $70 billion, or euros, I'm not sure. Dollars? Euros. To give you a sense of scale, how much 70 billion euros is for their income. If these were seconds, 70 billion seconds is close to 2,200 years. That's how big Enel is. That's why they need so much infrastructure. The blue line shows the daily costs of Enel. For those who have Superman eyesight, you can see that it starts off somewhere close to 85,000. There's an upward trend close to 100,000, and then it starts going down. Here we see the time scale. We only worked on data from January, February, March, and April. During the first 2 months, you see the upward trend. During the next 2 months, you see a downward trend. The downward trend is the hard work of the IT&S department, infrastructure, into information technology and services department, who was campaigning heavily during these 2 months. Did I get it wrong? I see you laughing. I got it wrong. Okay, IT&S. So they did heavy campaigning in terms of identifying underused instances, communicating heavily with users inside of Enel, trying to raise a sense of responsibility. And they managed to start bringing this down. So this is a monster that was going up, and they managed to do it through their manual work. The green line is the absolute theoretical world where people are billed by 5-minute intervals on just how much exactly they use on Amazon. This is not achievable, but this just gives us a sense of where a perfect world could be. The orange line is something theoretical that we believe is achievable. And this is close to 40% savings, from close to 100,000 to 60,000. And with our solution, we managed to get half of that theoretical savings. So we managed to show Enel exactly a concrete method to reach 20% savings. 20% on 50 million, that's $10 million per year. Our results, we came up with a solution that shows a set of concrete steps that Enel can take for each group of instances. We start off with $11.5 million spent during the first 4 months. By just terminating and stopping some machines, they can save 400,000. By using the Lambda function service from Amazon, they can save another 90,000. And so on and so forth, all the way to $8.7 million. So that's $2.8 million of savings in 4 months if they had taken these actions. This is Raja, this is me, and this was the AWS Resource Optimization Project.